Okay guys, we've made it. This is lesson 2.1. We're going to talk about functions for this whole unit. So today we're going to actually start by talking about what a function is and how we can recognize if something is a function. So a function is a relationship where each input has only one output, So the first question you ask yourself is a value of x repeated? So when you're looking at, let's say, the set of ordered pairs, right here. So we have a 1, and then we have a 3, and then we have a 1 again. Is the value of x repeated? Yes. Yes, it is. Are the y values the same? So the y value here is a 2. The y value here is a 4. Are they the same? No. So this one is not a function. Now, a lot of times it asks you to explain why isn't this a function? Because remember, each input x can only have one matching output y. So the input 1 does not have the same y. So the first time it has a 2, the second time it has a 4. Okay, so let's try this next one. We have 0, 1, 5, 0. Values of x repeated? Yes. We have a 2 and a 2. Are the y values the same? Yes. So this is a function. And why is it a function? Because each x has only one matching y. Okay, so let's look at that. So those were ordered pairs. Let's look at a table. So here's my x. I have a -1, I have a 4, I have another 4, and I have a 7. So if they repeat, they have to match. 1 and 3 do not match, so this is not a function. Why is it not a function? Because the input 4 does not have the same y. Okay, so this is called a function map. So this is your x, this is your y. So 2, 1, 4, 3, 6, 2, 1, 6. Each x has only one matching y, so this is a function. Because each x has only one matching y. Okay, so let's look at this next one. -3, 2, -8, 2, 2, 7, 0, 7. This is a function because each x has only one matching y. Okay, so then sometimes you're given, instead of coordinates or instead of a table or instead of a function map, you're given a graph. So to deal with a graph, you do what's called the vertical line test. The vertical line test says that you run an imaginary vertical line across your graph. If it ever touches the graph in more than one place, then it's not a function. If it always touches the graph in only one location, then it is a function. So you draw it. Now remember, these go on forever and ever. So this is continuous. It goes on forever and ever and ever. So even if I draw the line out here, eventually, up in the clouds, it's going to run into it. Oops, I erased my M. There we go. But let's draw it where we can see it. It only crosses in one, so this is a function. This is really saying each input only has one output, because every time I put in a 2, I'm going to get 0, because that happens to be the spot where it crosses. But on this one, if I draw it in, it has 2 locations. So every time I put in this x, I'm going to get this y value and this y value. So this is not a function. Let's look at this one. Only crosses once, so this is a function. It doesn't matter where I picked, it only crosses once, so this is a function. And this one, now granted, I could put it out here and it would only cross once. But remember, if it says that it crosses more than once in any spot, so if I draw it right here, it's going to cross in 1, 2, 3 spots. So this is not a function. So that's how to identify a function. Now let's actually work with the function. So this is going to be evaluating a function. So this is a function, f of x. This is really the same thing as saying y equals. So if you're ever graphing and you see f of x, it really is just y equals. And what happens is this is the function that's happening inside this machine. So inside this machine is the 2x minus 1. Let's say we want to put in 5. So inside the machine, it takes 2 times 5 minus 1. So that's 10 minus 1. So it's going to spit out a 9. So how that works, you have to put the 5 in the machine. And that was 10 minus 1, which is 9. So now you have to tell the function when I dropped 5 in equals 9. So this is an important part right here because it tells you what number you put into the function to get the answer. It's a necessary part. Let's practice another one of these. I'm going to go up on this one since we don't have any room below. So this is an x squared minus 5 inside the machine. I'm going to drop in a negative 1. Now you have to use parentheses since it's squared. So negative 1 squared, negative 1 times negative 1 is positive 1 minus 5, which is negative 4. So the function g, when we dropped in a negative 1, gave us an answer of 4. Okay, let's look at this next one. We're going to drop in a 10. So negative 3 times 10 plus 2 is negative 30 plus 2, which is negative 28. The function h, when we drop in 10, equals negative 28. So this is evaluating functions. Okay, so those are all of your notes for today. So here's your practice problems. As always, you're going to do the odds. However, I would like for you to scroll on down with me here to the review. The review says complete all. So remember, when you take your assessment this next time, it's going to have all of the new material over functions, and we will also test again over all of the solving equations and inequalities that we did. So we want you to continue practicing by completing all of these. You only need to do the odds of the new material. If you want to do all of the new material, you can if you need extra practice. The answer key for this will be inside of Google Classroom so that you can check your answers and make sure you're doing them correctly.